Okay, so for this extension, we are talking about linear regression using your graphing calculator. So we want to have our graphing calculator out, and we are going to look at some specific screens on here that are going to help us. Linear regression is about looking at data. So data is going to be under the statistics button, which is stat right there. And so if we want to add data into our calculator, we can go to edit and we get some lists of data. If there's already something in there, you can go up to the top and it shows you your whole set of data, and you can clear it and hit enter and it will all go away. If you accidentally go up and hit delete, you'll notice now list one is gone. That is a problem. So we'll go back to stat and choose choice 5, setup editor, and it basically resets your editor, but it does also bring back all the data that was in list 1. So I do want to go up and clear the data and hit enter. Now I'm ready to enter in a new set of data. So let's go to here and we will enter in this first set of data using the independent variable as our list 1, which is x, and the dependent variable in list 2, which is y. So it says the weight of the student depends on the height. That means that the height is independent. So the height is my x, that's my list 1, and the weight depends on the height. So the weight is dependent, that's list 2, that's my y. So that's list 2. Okay. So I'm going to put this into list 1 and list 2 of my calculator. So list 1, the first data point is 61. And so I will put that in and hit enter. The next one is 63, then 65, 63, enter, 65, enter. You want to enter these in very carefully so that you don't mess up. Like, for example, if instead of 67, I tried to hit 67 and the 7 didn't get entered by my calculator, that is going to really change the whole rest of the problem. So be very careful entering your data. And I have 1, 2, 3, 4, 5, 6, 7 data points. 69, 72, and 73. So I have 7 data points, and you can see right here, it talks about L1 of 8. That means what is the 8th entry in your list 1. So I have 7 entries before that. That's good. I have 7 data points. Now I will go over to list 2, and I will enter in list 2. So 160, 170, 180, 190, 200, 220, and 230. Okay, it is important to note these are XY pairs. Each row is a coordinate pair. So your data should end at the same row. If one row is longer than the other, the calculator will say, I cannot do this, there's an error. I have an X without a Y, or I have a Y without an X. So you want to make sure that not only you typed it in correctly, but that they end in the same spot. Okay, now it says use your calculator to calculate the equation of the best fitting linear model. So I want linear and best fitting, another word for that is regression. So if we look up here, it says the way to do calculate the regression equation is to go to stat and then calc and then linear regression. So let's look at that. So we'll go back to stat. We'll arrow to the right for calc. And you see there's a lot of different things you can do here. There's even an arrow that you could go down even more. And you might also notice there's 2 linear regressions. One of them is number 4 and one of them is number 8. Number 4 is the one that we like because it looks more like y equals mx plus b. So we will choose that one. And then it's asking, hey, what do you want to use for your x? I want to use list 1. Yes. I want to use list 2 for y. And then I will go down to calculate. So it tells me all of this good stuff. You may not have anything below the b equals. You may be missing the r squared and the r. So in order to get those to show up, and you might not realize what those are for, but those are nice because that's your correlation coefficient. It tells you how good of a model that equation is for your data. So in order to turn that on, you can go to catalog, which is second 0, and then you see all these green letters on your calculator. You want to hit the one that goes to D, and then you can just arrow down until you get to diagnostic on. The R value is a diagnostic, and we want to turn it on, so we'll hit enter, and then we have to enter again to do it. And now, if you go back to stat, calc, and choose number 4 again, you should see that r squared and r value show up. So we're going to use this to now write our regression equation. So looking at what we got from our calculator, it looks very close to y equals mx plus b. And so my regression equation is going to be y equals 5 point. Now I'm going to round it carefully to 2 decimal places. So the 8 has a neighbor of 5, which says, hey, instead of an 8, that should be a 9. And then the b, I have negative 188.8. Again, I'm going to look at the neighbor, and the neighbor of that 8 says round up to 9. It's very important to round properly on these because you're going to use it in part B to predict something else. If you've rounded wrong, your predictions will be off. So now for part B, it says use the model. This equation is a way to model the data. Use the model to predict the weight of a student that is 58 inches tall. So what it's saying is the y, remember y is our weight, and x is our height. So it's saying, hey, if they're 58 inches tall, that means x is 58. And I'm trying to predict the weight, so I want to know what is y when x is 58. So in my equation, I will put the x, I will put 58 in place of the x. And then I'll just use my order of operations. I'll do this part first, or you can put the whole thing into your calculator. So you can just clear this out and say 5.69 times 58. You can hit enter or not, and then say minus 188.89. Minus 188.89. If you did it all in a row together, that would also work because your calculator will follow the order of operations. And so in the end, we get 141.13. So it's saying that y, or the weight, is 141.13, which you can see these are all round numbers. They're all like to the nearest pound. So I'm going to say that's approximately 141 pounds. So using that model, I can predict that if someone is 58 inches tall, based on this data, they probably weigh 141 pounds. See the next video for, oh no, wait, there's one more piece. There's part C. If you turn the page, you will see part C. I'm going to put it down here. So now it says use the model to predict a student's height. Let me bring this over to where we were. Did it do it? There it is. All right. Use the model to predict a student's height if they weigh 250 pounds. So now it's saying, what is the student's height? That's the X that I don't know, but I know that they weigh 250 pounds. So I will use the same model. Sorry, this got turned on the next page for your notes packet. And now I'm going to put 250 in for the Y. And then I will have to solve for x. So just like we did before, just a reminder, this was the equation originally. So now it's just a problem solving for x. So I will add 188.89 to both sides. And I want to double check that on my calculator. 438.89. And now I will divide both sides by 5.69. And then I will get the height. 77.13 inches. And that too, you could just round to 77 inches. That would be just fine also. So notice that we did round to what makes sense for the problem. Look out for another video for example number 2.